Definition: an angle is the union of two rays that share a common endpoint. In Figure 1.46, the angle is symbolized by angle ABC or angle CBA. The rays BA and BC are known as the sides of the angle. B, the common endpoint of these rays, is known as the vertex of the angle. When three letters are used to name an angle, the vertex is always named in the middle. Recall that a single letter or numeral may be used to name the angle. The angle in Figure 1.46 may be described as angle B, the vertex of the angle, or as angle 1. In set notation, angle B equals ray BA union ray BC. Postulate 8, protractor postulate. The measure of an angle is a unique positive number. An angle whose measure is less than 90 degrees is an acute angle. If an angle's measure is exactly 90 degrees, the angle is a right angle. If the angle's measure is between 90 degrees and 180 degrees, the angle is obtuse. An angle whose measure is exactly 180 degrees is a straight angle. Alternatively, a straight angle is one whose sides form opposite rays, a straight line. A reflex angle is one whose measure is between 180 degrees and 360 degrees. See Table 1.4. In Figure 1.47, angle ABC contains the non-collinear points A, B, and C. These 3 points, in turn, determine a plane. The plane containing angle ABC is separated into 3 subsets by the angle. Points like D are said to be in the interior of angle ABC. Points like E are said to be on angle ABC. Points like F are said to be in the exterior of angle ABC. With this description, it is possible to state the counterpart of the segment addition postulate. Consider Figure 1.48 as you read Postulate 9. Postulate 9, angle addition postulate. If a point D lies in the interior of an angle ABC, then the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. Use Figure 1.48 to find the measure of angle 27 degrees if and the measure of angle DBC equals 42 degrees. B. Measure of angle ABD equals x degrees and the measure of angle DBC equals the quantity 2x minus 3 degrees. Solution: A. Using the angle addition postulate, measure of angle ABC equals the measure of angle ABD plus the measure of angle DBC. That is, measure of angle ABC equals 27 degrees plus 42 degrees, which equals 69 degrees. B. Measure of angle ABC equals the measure of angle ABD plus the measure of angle DBC. This equals x degrees plus the quantity 2x minus 3 degrees, which equals the quantity 3x minus 3 degrees. Many angle relationships involve exactly 2 angles, a pair. Never more than 2 angles, and never less than 2 angles. In Figure 1.48, angle ABD and angle DBC are said to be adjacent angles. In this description, the term adjacent means that angles lie next to each other. In everyday life, one might say that the Subway sandwich shop is adjacent to the Baskin-Robbins ice cream shop. When 2 angles are adjacent, they have a common vertex and a common side between them. In Figure 1.48, angle ABC and angle ABD are not adjacent because they have interior points in common. Definition: 2 angles are adjacent, ADJ angles, if they have a common vertex and a common side between them. Definition: congruent angles are 2 angles with the same measure. Congruent angles must coincide when one is placed over the other. Do not consider that the sides appear to have different lengths. Remember that rays are infinite in length. In symbols, angle 1 is congruent to angle 2 if the measure of angle 1 equals the measure of angle 2. In Figure 1.49, similar markings, arcs, indicate that angle 1 is congruent to angle 2. Given, angle 1 is congruent to angle 2. Measure of angle 1 equals 2x plus 15. Measure of angle 2 equals 3x minus 2. Find x. Solution. Angle 1 congruent to angle 2 means that the measure of angle 1 equals the measure of angle 2. Therefore, 2x plus 15 equals 3x minus 2. Solving for x, 17 equals x, or x equals 17. Note, measure of angle 1 equals 2 times 17 plus 15 equals 49 degrees, and the measure of angle 2 equals 3 times 17 minus 2, which equals 49 degrees. Definition. The bisector of an angle is the ray that separates the given angle into two congruent angles. With P in the interior of angle MNQ, so that angle MNP is congruent to angle PNQ, ray NP is said to bisect angle MNQ. Equivalently, ray NP is the bisector or angle bisector of angle MNQ. On the basis of Figure 1.50, possible consequences of the definition of bisector of an angle are: measure of angle MNP equals the measure of angle PNQ. Measure of angle MNQ equals twice the measure of angle PNQ. Measure of angle MNQ equals twice the measure of angle MNP. Measure of angle PNQ equals 1/2 the measure of angle MNQ. Measure of angle MNP equals 1/2 the measure of angle MNQ. Definition. Two angles are complementary if the sum of their measures is 90 degrees. Each angle in the pair is known as the complement of the other angle. Angles with measures of 37 degrees and 53 degrees are complementary. The 37-degree angle is the complement of the 53-degree angle, and vice versa. If the measures of two angles are x and y, and it is known that x plus y equals 90 degrees, then these two angles are complementary. Definition. Two angles are supplementary if the sum of their measures is 180 degrees. Each angle in the pair is known as the supplement of the other angle. Given that the measure of angle 1 equals 29 degrees, find A. the complement x, B. the supplement y. Solution. A. x plus 29 equals 90. So x equals 61 degrees, complement equals 61 degrees. B. y plus 29 equals 180. So y equals 151 degrees. The supplement equals 151 degrees. When two straight lines intersect, the pairs of non-adjacent angles in opposite positions are known as vertical angles. In Figure 1.51, angle 5 and angle 6 are vertical angles, as are angles 7 and 8. In addition, angle 5 and angle 7 can be described as adjacent and supplementary angles, as can angle 5 and angle 8. If the measure of angle 7 equals 30 degrees, what is the measure of angle 5 and what is the measure of angle 8? Is it true in general that vertical angles are congruent? Recall the addition and subtraction properties of equality. If A equals B and C equals D, then A plus or minus C equals B plus or minus D. These principles can be used in solving a system of equations such as the following: x plus y equals 5, 2x minus y equals 7, 3x equals 12, left and right sides are added, x equals 4. We can substitute 4 for x in either equation to solve for y. X plus y equals 5, 4 plus y equals 5, by substitution. Y equals 1. If x equals 4 and y equals 1, then x plus y equals 5 and 2x minus y equals 7. When each term in an equation is multiplied by the same non-zero number, the solutions of the equation are not changed. For instance, the equations 2x minus 3 equals 7 and 6x minus 9 equals 21, each term multiplied by 3, both have the solution x equals 5. Likewise, the values of x and y that make the equation 4x plus y equals 180 true also make the equation 16x plus 4y equals 720, each term multiplied by 4, true. Construction 3. To construct an angle congruent to a given angle. Given angle RST in figure 1.52a. Construct, with ray PQ as one side, angle NPQ congruent to angle RST. Construction. Figure 1.52b. With a compass, mark an arc to intersect both sides of angle RST at points G and H respectively. Figure 1.52c. Without changing the radius, mark an arc to intersect ray PQ at K and the would-be second side of angle NPQ. Figure 1.52b. Now mark an arc to measure the distance from G to H. Figure 1.52d. Using the same radius, mark an arc with K as center to intersect the would-be second side of the desired angle. Now draw the ray from P through the point of intersection of the two arcs. Just as a line segment can be bisected, so can an angle. This takes us to a fourth construction method. Construction 4. To construct the angle bisector of a given angle. Given angle PRT in figure 1.53a. Construct ray RS so that angle PRS is congruent to angle SRT. Construction. Figure 1.53b. Using a compass, mark an arc to intersect the sides of angle PRT at points M and N. Figure 1.53c. Now, with M and N as centers, mark off two arcs with equal radii to intersect at point S in the interior of angle PRT as shown. Now draw ray RS, the desired angle bisector. Reasoning from the definition of an angle bisector, the angle addition postulate, and the protractor postulate, we can justify the following theorem. Theorem 1.4.1. There is one and only one angle bisector for a given angle. This theorem is often stated: the angle bisector of an angle is unique.